Okay, for problem 15, we have an arithmetic sequence. A sub n has terms a2 equals 14, a2 equals 14, and a9 equals 56. And we're supposed to find the sum of the first 14 terms. So we're supposed to find the sum of the first 14 terms. So we're summing from the first term to the 14th term. And our equation there, well, one of the equations we could use, there are several different ways you could do this problem. And I'm going to approach it as we're going to find the a sub n. So what I'm going to try to do is I'm going to try to find a of 14 and then use this formula for the sum of an arithmetic sequence to solve our problem. So in order to be able to find a sub 14, I've also got to use our general formula for a sub n of an arithmetic series, or arithmetic sequence. And so a sub n, we have a1 plus the common difference d times n minus 1. And before we can do anything else, we've got to figure out what d is. We've got to find d. And so in order to find d, I'm going to take a look at my a2 and my a9. So what I'm going to do is I'm going to subtract a2 from a9. I get 56 minus 14 is equal to 42. And there are 7 terms between a sub 2 and a sub 9. So if we divide that by 7, we get 6. So our common difference here is 6. And of course I can take 14, subtract 6, and get 8. So I know a sub 1 is 8 plus our common difference is 6. That's what we found right here. And then we're going to multiply that times n minus 1. Well, we're trying to find a sub 14. So that's 14 minus 1 is 13. So when we're trying to come up with a sub 14, we get 8 plus 6 times 13, which is equal to 86. Okay, so we're going to return to this formula right here that I'm highlighting, because now we know everything we needed to know. We know a1, we know a sub n, we know everything that we need to know, so we can plug that in. So we'll have 14 over 2 times a1, and we figured out down here we figured out, okay, a1 is 8. So we have 8 plus, and a sub n would be a sub 14, which we just found here, which is 86. So that's going to give us 7 times 94, and 7 times 94 is 658. And that's our solution for problem 15.